All right, this video is going to be on forces right from the beginning. So there's a few things you have to ask yourself when we are doing a force style problem. What forces are in this scenario? The types of forces you could encounter is your gravitational force. It is identified mass times gravity, right? Mass times acceleration. Here, acceleration due to gravity. This force is on every free body diagram, and I always write it as mg. You could have tension. This is the force on a string. If you have a string, you have a tension force. There is a force normal. This is a surface force. It always acts perpendicular to the surface. If you have a surface, you have a normal force. Friction is also a surface force. You can have a static friction or kinetic friction. Friction is if you have a rough surface. So static friction keeps an object stationary, and kinetic friction is when you're moving. We will do more with the difference between the two later this week, but you either are at rest or you are moving. So if you are at rest, you have static friction. If you are moving, you have kinetic friction. And oftentimes it's identified as F sub S for static friction, F sub K for kinetic friction, and it will take you more force to get you moving because of your inertia. So most of the time your static frictional force is going to be greater than your kinetic frictional force, or your coefficient of friction, I should say. So your mu is your coefficient of friction. And we can relate our force normal and our frictional force with one of the equations on our equation sheet. This comes in handy when we take a look at our free body diagram scenarios and solving for forces. Let's see, what else? Gravitation, tension, force normal, friction. You can have an applied force. Right, this is a push or pull. You can have a spring force. This is when you have a spring. Your spring force is equal to negative kx, which is your spring constant and measured in Newton per meter. And then this is your displacement. Measured in meters. Anyway, we will not do a lot with spring force this unit, but when we do simple harmonic motion, we will take a closer look at that. All right, I think that's all for these forces. We are going to take a look at some free body diagrams and identify the forces that are going on here. I'm going to do a few for you, and you guys are going to do the rest on your own for today's assignment. So I'll skip a few and do some harder ones. Not harder, but ones that have more, so you can take a look. So number 4 says an object is sliding on a frictionless incline. That means that there's no friction along the surface, but I'm going to draw my gravitational force from the center of my mass, and then I have a surface, so I'm also going to draw a force normal here. And since it's frictionless, right, I would not draw a frictional force along here. Similarly, let's do this one. So we've got mg down, always drawn from the center of my mass. You've got force normal up. Force normal is the surface force, so it needs to be drawn from the surface. And then this does have friction, so I'm going to draw along the surface of my plane my frictional force. So since this is moving, right, this frictional force is going to be kinetic, a kinetic frictional force. This one says inclined plane friction prevents sliding, so you would have your mg down. You would have your force normal perpendicular to the plane, and this thing is going to want to be sliding down the plane. So we have to draw our frictional force opposite. So whichever direction the object wants to be moving, we're going to draw our frictional force in the other direction. And this is going to be static frictional force because it's at rest. Let's do this one with tension. And I'll do maybe one more and you guys can try the rest. So an object that is motionless. So we're on an incline, so I've got my mg down. And I have my force normal perpendicular to my surface. And I also have this tension here. So this free body diagram. So we are drawing all of these on the objects themselves, but oftentimes you just draw it from a point. So if I were to draw this free body diagram from a point, I would draw all my forces coming from the point. So this is tension. So tension and my force normal here are going to be perpendicular to each other. So you can draw that on your diagram. Here, my force normal and my frictional force are also perpendicular to each other. My force normal, my frictional force, and my mg, these are all 90 degrees from one another. Let's do these two. So terminal velocity means that my air resistance is the same as my mg down. So these two forces are equal in magnitude. Air resistance is a frictional force, right, just in the air. And this last one I'm going to draw is as the ball is rising in a parabolic trajectory. Do not neglect air resistance. So you've got your mg down, and your frictional force is acting opposite your motion. So if this motion is going this way, right, I would draw my frictional force or my air resistance the opposite direction of the ball. All right, try the rest and let me know what you think.